Direct exposure assessment is a method used to measure or estimate the amount of a hazardous substance to which a worker is directly exposed in the workplace. This method involves collecting data on the exposure pathways, concentrations of hazardous substances in the air or on surfaces, and the duration and frequency of exposure. Direct exposure assessment methods typically involve using monitoring equipment such as personal air sampling pumps or direct reading instruments to measure the concentration of hazardous substances in the air around the worker. The data collected is then used to calculate the worker's exposure to the hazardous substance over a given time period. Other direct exposure assessment methods may include collecting samples of dust, soil, or other materials that could contain hazardous substances, or using wipe samples to measure the amount of a substance present on surfaces. Direct exposure assessment is an important component of industrial hygiene and is used to evaluate the effectiveness of control measures and to determine whether further action is needed to protect workers from hazardous substances in the workplace. The data collected through direct exposure assessment can also be used to establish exposure limits and to develop strategies for reducing or eliminating worker exposure to hazardous substances. Indirect exposure assessment is a method used to estimate the potential for exposure to hazardous substances in the workplace when direct measurement is not feasible or practical. Indirect exposure assessment methods typically involve using available data and information to estimate the likelihood and magnitude of exposure. Examples of indirect exposure assessment methods include: modeling. This method involves using computer models to simulate the release and dispersion of hazardous substances in the workplace and to estimate the resulting exposure levels. Workplace surveys and questionnaires. This method involves collecting information from workers about their job tasks, workplace conditions, and exposure history to estimate potential exposure levels. Exposure databases. This method involves using historical data on workplace exposures to similar hazards to estimate potential exposures in a new situation. Expert judgment. This method involves relying on the knowledge and experience of industrial hygienists and other experts to estimate potential exposures based on the available information. Indirect exposure assessment methods can provide useful information for identifying potential hazards and for prioritizing areas where direct measurement should be conducted. However, they may also have limitations due to the assumptions and uncertainties involved in the estimation process. As a result, indirect exposure assessments are often used in combination with direct exposure measurements to provide a more complete picture of worker exposure to hazardous substances in the workplace. Industrial hygiene is a field of study and practice that focuses on identifying, assessing, and controlling workplace hazards that can affect the health and well-being of workers. Industrial hygiene typically focuses on identifying and managing exposure to physical, chemical, biological, and other types of hazards that can be encountered in industrial settings. The goal of industrial hygiene is to ensure that workers are protected from potential hazards and to prevent occupational illnesses and injuries. Industrial hygienists use a variety of methods and tools to assess workplace hazards, such as air sampling, noise monitoring, and ergonomic evaluations. They also develop and implement control measures to minimize or eliminate worker exposure to these hazards. Examples of industrial hygiene activities include conducting risk assessments, evaluating exposure levels, developing and implementing control strategies, training workers on hazard recognition and control, and conducting audits to ensure compliance with regulations and best practices. Industrial hygiene is an important aspect of workplace safety and health, and is critical to maintaining a safe and healthy work environment for employees. Hazard classification is a way of categorizing hazards based on their nature and potential for harm. The following are common hazard classifications for psychosocial, biological, physical, ergonomic, and chemical hazards. Psychosocial hazards. These are hazards that arise from the nature of work and can affect workers' mental and emotional well-being. Examples of psychosocial hazards include workplace violence, harassment, stress, and bullying. Biological hazards. These are hazards that can cause harm to workers through exposure to biological agents such as viruses, bacteria, or fungi. Biological hazards can be classified into 4 categories: viruses, bacteria, fungi, and parasites. Physical hazards. These are hazards that can cause harm to workers through exposure to physical factors such as noise, vibration, radiation, or extreme temperatures. Physical hazards can be classified into 3 categories: mechanical hazards, radiation hazards, and environmental hazards. Ergonomic hazards. These are hazards that can cause harm to workers through repetitive or awkward motions, poor posture, or other ergonomic factors. Ergonomic hazards can be classified into 2 categories: biomechanical hazards and organizational hazards. Chemical hazards. These are hazards that can cause harm to workers through exposure to chemical agents such as gases, liquids, or solids. Chemical hazards can be classified into 4 categories: physical hazards, health hazards, environmental hazards, and hazardous processes.